where we can talk about a project, and then during break we can actually go walk through the project and actually see what we're talking about and point out some of the issues that we had. So I think that's a really unique thing that we're going to be able to experience today. So I'm really excited for all of you to be here and share this with us. As Martin said, we do have a vast range of participants here in the audience today. Some of you are experts in life cycle assessment, and some of you probably have never heard that term until today. So we're going to try to make it understandable for those who maybe aren't as familiar with it, but even for those who are experts in it, I'm hoping that you can still maybe see a new way to communicate an issue or a new tip or trick or process to follow. So hopefully everyone here will really get something out of the day, no matter your level of expertise or familiarity with the subject. So I'm going to start introducing embodied carbon. Embodied carbon is actually what we're measuring, one of the things we're measuring when we talk about life cycle assessment. So there's a lot of terms, and we're going to try to make sense of them all for you today. An embodied carbon is basically all of the carbon associated with a project, a building, an asset, other than the operational carbon. Normally when we talk about carbon of a building, or a green building for example, people are normally talking about the annual operating energy of a building. How much energy it takes to have the lights on, to have the heating on, to have the cooling on, to power your laptop and your iPod and all those things, and the things we're plugging in the wall. That, until very recently, has been all that we're thinking about when we're talking about energy or carbon of a building or greening a building. But as you can see in this picture, there's a lot of other factors and phases and inputs that go into creating a building, right? Steel and concrete and glass don't just appear on the building site with no carbon footprint, but that's really how we've been treating them up until now. So embodied carbon is really the carbon associated with all of the phases of getting all of the inputs to the building, using them, constructing them, repairing them, maintaining them, and then decommissioning them at the end of the life cycle of the asset. So as you can see, the red use phase operating carbon is really but a small piece of the larger whole, which we're trying to look at. And you can see at the bottom of the picture here that embodied carbon is quite significant. It's estimated that it's about 20% of the construction sector's emissions and about 11% of total global GHG emissions, which is quite a big piece that up until quite recently people haven't even thought about, let alone started to track and measure and reduce. And when I talk about life cycle carbon or embodied carbon, I like to make the connection to money, because people know about money. They've thought about money more than carbon probably in the past. And life cycle costing is something that people typically are familiar with or they've heard about. I remember hearing news reports about the F-35 fighter jets in the news a couple months ago now, and they were talking about the life cycle costs of the jets. They included the 30-year maintenance contracts and the end of life, whatever they're going to do with the jets. But they were reporting numbers and stating these are life cycle costs over a 30-year or whatever the lifespan was of the jet asset. And I thought, haven't really heard that too much in the past, but it's interesting that we're starting to make decisions on big government purchases using life cycle costs. It's the exact same thought with carbon, the same approach to carbon. We shouldn't just be thinking about how much carbon we're using annually every year, but the total life cycle. So I just like to make that connection because people do think in life cycle costing terms often nowadays, or they're starting to. So let's create that shift also on the carbon side. The other reason I want to bring it up is to say that those are two different things. Sometimes people hear life cycle and they think, oh yeah, we do that already, and they're thinking about life cycle costing. But there's two things here, right? One's the dollar amount, life cycle costing, and the other is life cycle carbon or life cycle assessment. When people say life cycle assessment, they're talking about typically the environmental impacts associated with the whole life cycle, carbon being one of those things, but that's separate from cost. So just trying to make those delineations there. So this graph just shows what the typical carbon profile of a building in Ontario looked like yesterday or in the past, hopefully not anymore, where a vast majority of the carbon associated, and sorry, this is year one is construction here, so this is right when the building opens. There's been no carbon used or no energy used for operating that building yet because the lights haven't been turned on, the heating system hasn't been turned on, but the building was just constructed. So we do have that big hit of embodied carbon on day one, or before day one, and that is basically maintained throughout the whole life of the building because all those materials are required and they remain. But operational carbon steadily climbs over time. Every year, as we're using our lights, we're using our energy, that's the operational carbon is going up every year. And in the past, operational carbon was significantly more than embodied carbon. So when you look at a graph like this, and someone says to you, oh, let's make sure we reduce our embodied carbon, a good engineer would say, well, maybe not. Operational carbon is really what we should be focusing on because it's by far the biggest input of the issue here. But that's not what buildings look like today, at least high efficiency buildings. That's what they look like today. We've been legislating and reducing our operational energy use and thus carbon for the past 30 years, 40 years. I believe the first Ontario Building Code to include operational efficiency requirements was released in 1975, and every update to the Ontario Building Code has ratcheted down that requirement and required a more efficient building. So we've been doing a really good job over the past 30, 40 years at reducing operational carbon. And new buildings now that are high efficiency, they look like that. It takes basically 60 years for the operational carbon now to be the same level as what the embodied carbon is. So when you look at this picture, you say, oh, actually, embodied carbon is a serious piece of the pie, and we do need to start looking at it and measuring it. And it's even more striking if we talk about the next 10 years or the next 30 years, or the time frame that we really need to make significant reductions in our GHG emissions. Right? If you look at that, if you were to, I should have put a line there at 20 years or where we're setting our long-term goals to, but if you look at that time frame, the majority of the emissions for our new buildings today are from the structure, and we're not even looking at that. People aren't even measuring that typically. Evergreen is, they're a leader. Some people are, and that's the point of today. If you don't remember anything else about today, remember these slides, and that embodied carbon might not have been an issue before, and might not have been something that buildings, it made a lot of sense to invest time into to tackle, but it definitely does now. But that's not the end of it. This is what we really need things to look like, because having less emissions is not the end goal. It's really having zero emissions, or having negative emissions, having regenerative infrastructure and built communities. So this is what we're trying to aim for, a reduced embodied carbon profile. I'd like to see that line even smaller, to be just a little thin blue line, but I need to show a visual here. But we want that blue to be as small as possible, and then we want the operating emissions, if you will, to be negative. We want to have net zero buildings that are actually creating more energy than they're using, and over time, they can actually offset the total embodied carbon that went into the building. We could even be more aggressive than this. I was recently at some conferences where people are talking about using carbon sequestration materials, right? The material itself that doesn't have an emission, it's a negative emission because it's made of vegetative materials that won't degrade after it's been produced into some kind of a building block. So it actually locks carbon out of the atmosphere, and it remains in that form. So there's a lot further that we can go, and we've made, as I said, we've made a lot of great progress in the past 20, 30 years, but there's more we can do, and there's more we have to do. As we can see, every year we're seeing more extreme weather events, higher intensity and frequency, and they're just going to keep going. People are talking about the new normal, but we're not at a new normal, we're in no way at an equilibrium. Things are going to get a lot worse before they get a lot better. So we really do need to take this seriously and act. This picture shows what a typical green building might say. You've probably read a lot of press releases on LEED buildings and new structures, and this is a common statement. Our green building uses 25% less energy than a standard building, and maybe we could have a picture like this, which is great. But what about if we look at the other life cycle phases? We might, because when they're talking about uses less energy, they're really talking about the operational energy, right? The annual energy that's used to turn on the lights and keep the building heated and cooled and those things. They're not talking about where the material came from. how it's going to be maintained, how it's going to be decommissioned at the end of the life cycle. So when we add all of those life cycle phases in, it might very well be the case that the green building may have a bigger impact and more carbon than the green building. Not saying that this is always the case, but just an illustrative example that just looking at the operations doesn't give you the full picture. And why are we talking about energy anyways? That's not the issue, that's not really the enemy. It's a proxy for the enemy, which is carbon, but we're starting to decouple that link between energy and carbon as we're greening our electricity grid. So we really need to be focused on the thing we're really trying to reduce, which is life cycle carbon, not operational energy. So there's three main reasons what I like to say, that I like to bring up as why this is important. One is buildings are becoming more energy efficient. We showed that graph before where the triangle has shrunk. So embodied carbon is a bigger piece of it. Two is energy is becoming more cleaner, as I just alluded to. If we have a 100% green electricity grid, saving electricity doesn't necessarily or at all address carbon emissions. A lot of people don't really make that link. Not saying, obviously there's other reasons to be efficient. I'm not saying use as much energy as you want if it's green electricity, but we need to be aware of that. And if the goal is reducing carbon, then just reducing electricity might not necessarily be achieving that. And the third is that we need to reduce emissions now, not over the next 60 years. Well, yes, over the next 60 years, but it's more important to have a short-term reduction to maximize our short-term reductions to meet these strategy or these targets we're talking about. So when you look at the next 10 years, it's really embodied carbon is the big opportunity there. And I've talked about this already, but this is how things looked like in the past, where operating energy consumption was a huge piece of the pie. That's what they're going to look like in the future. So we better start understanding these material embodied carbon emissions and reducing them. I think I already talked about all these things. I kind of just talk on the intro slide and forget that I have slides where I'm supposed to discuss in more detail later. So yeah, the other thing to think about it in the grid aspect, or that operational savings doesn't necessarily link to carbon savings, is things like how we're creating our electricity. In some regions, reducing the electricity may have a very big impact if it's a grid that the electricity is produced using fossil fuels, right? So areas like Alberta or a lot of places in the States, they have a very different fuel mix in their electricity than Ontario does, or BC or Quebec. So you always have to keep that in mind as well. When you read studies about carbon emissions and savings in electricity, you always have to ask what region was this study created in, or what values were they using, because a report from Alberta might have a very different approach or very different results than a report from Ontario. And also the climatic conditions plays a huge role as well. I've compared a lot of embodied carbon studies and saw operational emissions were hugely different in a project in Vancouver versus Toronto, and it was really the climate was the big change in that one. It wasn't necessarily the grid, even though the grids were slightly different, but Vancouver has a lot less heating requirement than Toronto does. So Toronto uses a lot more, buildings in Toronto use a lot more natural gas, which has emissions associated with that. So you really have to be aware of the individual realities, not just of the grid, but also of the climate when we're talking about these issues. I like to show this slide just to show people how green our electricity mix is. This was a slide from my research supervisor at U of T, Chris Kennedy, who I'm sure a lot of you know. And it just shows different regions around the world and the carbon content of their electricity over time. And you can see there's all those countries up there, and Canada is the gray one here near the bottom. Very low electricity, carbon content of our electricity, and that's Canada as an average. So when you look at just Ontario, we're down here in this red line below Brazil. So this is just to show that, sometimes we read studies or read, strategies in other countries, and we should really remember that their electricity grid is totally different than ours. We have a very, very low carbon grid, so we need to be creating made in Canada approaches due to our great starting position. emission. This is a great thing. I'm just saying it means what we should be focusing on is probably not what those guys should be focusing on. We should be focusing on embodied carbon and reducing natural gas consumption. And the third reason, which we mentioned, is that we really need to make these requirements in the short term. There's a huge amount of reductions that are required over the next, X years to hit our targets, and we don't have that much time to get there. When you look at a typical life cycle of a building and where the emissions come from, if we're between year 0 and year 5, it's almost all embodied carbon. What's the next one there is 60 years, so that's what it might look at over 60 years, but as I said, when we're making short-term reductions, it's really embodied carbon is a way that we can achieve those immediate goals. And I'd like to show this slide as well to think, are we really measuring all of the environmental impacts of our projects? If you look at those the top two materials there, those two materials have the same thermal resistance, so they would treat, the amount of emissions or the amount of heating or cooling required of a building that are built out of those two materials would have the same amount of impact. But clearly they're very different materials, right? Without even knowing the details, one of them is a natural product that is grown from a forest, that creates ecosystems, that creates biodiversity, that sequesters carbon out of the atmosphere. And the other one, it may have negative emissions, it may have a lot of landfill processes, it may not be recyclable, and those would not be at all quantified or measured if we just looked at the emissions or the operational impacts of a building. So there's really vast differences in the approaches we can make in the impacts from the material decisions that we're making these days, and we really need to start thinking more holistic and looking for ways to reduce these other environmental impacts. So hopefully that gives you guys a good idea or a good introduction to what we're talking about when we're saying embodied carbon and why it's an important thing to tackle. I'm going to hand it over now to Daniel from U of T, who's going to talk more specifically about life cycle assessment, which is the process we use to measure embodied